All right. Thanks for signing in, folks. Jacob will jump in and give his presentation on risks from AI.
So this is just a presentation. It's hard to convey a lot of the counter arguments and nuance here. So keep that in mind and be skeptical about whether these things are true or false. The main worry I have with giving presentation is that people will take the ideas and then go do things without really consulting with anyone or just generally do unhelpful or harmful things. It's kind of complicated to think about what might be helpful here. I would consider downsides and risks pretty carefully. There's going to be a ton of different slides. The basic idea of these can see some past AI winters, some notes about different capabilities of systems, notable breakthroughs, when systems surpassed humans at recognizing images, how long it takes to go from starting to apply AI to the task, to AI beating humans at the task, to AI beating the best humans, to AI going far beyond humans. And that's a theme that we talk about later. You might draw something like this. This was presented to me in a course I took about computer vision. This is misleading because we've had 11 years since this last supposed peak of hype. I asked GPT-4 to summarize some of the progress since then, and I'll just highlight that Alpha Zero is a pretty interesting one to think about because it became one of the top programs at playing Go and also games like chess, and it did it mostly through self-play without even taking in human knowledge, and it did this all overnight. That's how long it went from starting its training to finishing its training at a point where it was one of the best programs out there and could beat humans. Some AI history stuff, I'll just TLDR some of these. So systems are becoming more efficient at achieving the same performance as previous best systems. So this was AlexNet for classic images. As a result, and a result of other factors, the cost is going down of training a system as good as AlexNet. We're also just seeing a lot more money going into AI. I'd be curious to see what this looks like for 2022 and this year. I think we saw 10 billion alone from Microsoft to OpenAI, so that would already be half a rung up on this chart. This one is the size. So we're seeing networks that are getting to larger and larger scales, just in terms of the number of knobs that we're tuning. The parameters basically control what model you get as your output. And notable thing is that y-axis is on a log scale here. So this is exponential growth. We're also seeing more computational resources being spent on AI systems overall. Again, this is a log scale. This is a kind of important thing for looking at potential risks. Maybe we can get a lot of results out of just scaling up models. This is how much of the biggest results are coming from academia, partly because things involve such a large scale and like heavy amounts of computational resources. So I'd say the overall takeaway here is that we're in the hands of top AI labs and corporations running different AI models. Maybe it's even worse. So in the United Kingdom has less than 1,000 of the top of the line GPUs, which are really important for leveraging computational resources. So that one private lab in California, they're talking about OpenAI, is maybe doing 25 times as much computation or has access to that much as the entire United Kingdom. Perhaps worrying if you think about the way decisions get made and the distribution of power. Another trend, more publications happening. So this is about a doubling since we saw the start of the deep learning revolution. This chart makes things look a little bit more extreme, maybe because it goes back further in time. What I do want to highlight about this chart is someone's anecdotal reaction to it. So Andrej Karpathy is a pretty famous AI researcher. It feels like things are moving very fast at a subjective experiential level. Karpathy is a really good researcher and he works at OpenAI now. Seeing things moving fast, here's another perspective on this. So looking more at the benchmarks when we're measuring how good models are. These two people work on AI policy and governance stuff. And yeah, the overall thing is maybe we can get reliable progress mostly from using more parameters, more data, more computational resources, rather than coming up with some fundamental new algorithmic breakthroughs. If that's the case, then we should definitely start preparing now for any potential risks because we could really advance AI in the near future. Here you can see a bit of the scaling hypothesis at work. This was one of the image generation models from last year. It's certainly better than me at all of these scales, but it doesn't really match the prompt until the largest number of parameters, 20 billion parameters. Overall picture I want to paint is that maybe things are moving too fast. A couple of reasons this might be bad. One is you just have less time to solve the technical and engineering and theoretical challenges involved in making really powerful artificial systems that do something in the ballpark of what we want. There's not much research happening on this right now, and it will be hard to get a lot done if we don't have much time. It'll be hard to get a lot of other stuff done too. Perhaps you think the world needs to prepare for coping with some of the impacts of AI. Maybe there will be some misuse risks or some
destabilizing dynamics. For example, deepfakes could enable a lot of misinformation, or maybe widespread unemployment causes some chaotic, undesirable trends. Overall, it seems like you might want other stuff, just technical and engineering work, especially for effective altruism software engineers. You might have noticed that maybe some of today's global values are not something that you personally think are very good for the world. Maybe factory farming is a key example here. Maybe some authoritarian regimes could be a key example. But if you're moving really fast, you might just have to make a one-time decision that ends up getting stuck, a sort of irreversible setting in of the AI systems that we choose to build and what values they end up pursuing. If you're moving more slowly, you might be able to do some sort of long reflection type of thing where you can really ponder deeply what kind of values you want to be putting into these systems. It looks like more realistically, we will have no time for that, which seems bad. I'm going to go into more on the speed side. Let's look at, is this all overblown? We just looked at some anecdotes and charts. What do the experts think? So this was a survey from AI Impacts, came out last year. Maybe it was done the year before. Obviously, there's limitations in survey data. Overall, about 90% of the people surveyed said that we would probably be able to get human level artificial intelligence, 50-50 shot at getting it within the next 100 years. So 50-50 shot seems high enough that we should definitely be taking it seriously. And 100 years doesn't seem like that much time, I would say. You may not think that the experts actually have a very good opinion on this. They specialize in building the technology. They know a lot about their specific subdomain of expertise within it, but there's probably a lot of other relevant factors to consider when projecting future progress. Economic trends seem to be a big one. You can do a bit more of a computational and quantitative model of this. So this is Jakub Kraus' BioAnchors report, where the idea is, let's try to estimate how much computational resources the human brain is using. This is a very high level sketch. And then see when we could be able to use that much computational power in an AI system. We actually already do have maybe 10x more computational power than the human brain in some of the best supercomputers, if you do the estimates a certain way, but we don't have human level AI yet. An AI system will be consuming the resource of floating point operations in a different way from a human brain. So just because you have enough of a resource doesn't mean it gets translated into the same outcome. So an example of this would be like human brain uses like 20 watts of power, but 60 watt light bulbs aren't intelligent. Let's see when we can get computation enough to match the human brain. And one problem there is you probably need more computation to train the model than you do to actually run it at inference time or test time. Here are some of the predictions. So let's look at 50%. She aggregates over 6 different possibilities for how much computation you might need. 50% is about a few decades from now. Notably, she revised her predictions recently to say that she thinks maybe we should put more probability on sooner outcomes. Another thing you can do is do a literature review of all the different people doing predictions here. Some of these are model-based, like Jakub Kraus, which we just looked at. Some of them are based on forecasters, like, I don't know how to pronounce this, but somewhat Sveti, team of people predicting the future that has done historically really well at predicting different events. So you can see what they predict, and then you can do different kinds of aggregating to come up with a final tally that uses your guess for AI timelines, which is how long before human level AI. So notably, 2030, between a 8 and 25% chance, depending on which one you're looking at. That's really high. If you just had a kid born right now, that would be when they hit second grade or something. Another interesting model report is looking at how long do you go from when AI can do maybe 20% of all the cognitive labor in the economy. That might be hashed out as doing anything that a human could do remotely, so remote work, and then see how long you go from there before artificial intelligence can do 100% of the tasks. This is a report by Tom Davidson at Open Philanthropy, looking at a lot of different economic modeling techniques. It found that it would take about 4 years is the estimate shown here with these particular parameters. That's really fast. We might not have much time to respond adequately, and this seems to present a lot of challenges. Especially, I would argue, once we're closer to the most advanced systems, that's when we can do a lot of really productive research, potentially on making them safer. We might have the assistance of the systems themselves, and we also can see more closely what are the really transformative systems, what do they actually look like. So we want a lot of time in this band, but 4 years doesn't sound like very much. A lot of interesting model-based quantitative work. The model also predicts, I think, shorter timelines to human level AI than Jakub Kraus' model. And it also gives some insight on how long you go from doing 100% of human tasks and cognitive labor to doing all these tasks much, much better than humans. So maybe you would call this something like super intelligence. And that time was between 1 and 12 months. So that is very hard to wrap my mind around personally. It's something like that pace of change. It's interesting to not only think about time before really advanced AI that can do a lot of human tasks, but also time from that level of AI to far beyond humans. And maybe you think that latter one is even more scary and risky because the systems would be, in a broad sense, smarter than us. Okay, weird things happen in the world. I'd claim that if you went back to the 1700s and told your ancestors about what your life is today, they'd be really confused when you tell them about Zoom or FaceTime or the foods you eat, the house you live in, the clothes you wear, the car you drive, the school you go to. Most things about modern life are really weird and sci-fi to people in the 1700s, or even to people at the start of the century, like maybe your great grandparents. You could look at electric power and see how long it took for that to get adopted into US households. This is US households, I point out. So for the internet, you can see maybe close to 90% of US households have internet, which already seems surprising. Like, wow, 10% of people don't have access to the internet, but it's actually worse. So worldwide, I think over a third of the world doesn't use the internet. You can look at, have they ever used the internet, or have they used the internet in the last few months or something? A really startling number of the world isn't even at the same place as we are today. So again, pushing on this, the world has been changing really rapidly already. Maybe it shouldn't be that surprising to imagine AI also causing really rapid changes that I would claim we're not really prepared for. Another thing is look at when the first human-powered airplane went off. And then in about 66 years, we were already on the moon, which, whoa, that's a lot of flight progress really fast. The last year might fit into the 21st century like this, 2001 until 2013, 2014. The first iPhone is a notable event that really changed the world. We saw social media on an earlier graph. Not clear if that change was positive. This might seem like, wow, so much has changed since then, but you can go even further and think about, when did humans even come into existence? A lot of the progress we're seeing, like going from an airplane to flying on the moon in 66 years, is really fast compared to everything that preceded it. You could go further and look at when the first life forms showed up, when Earth was formed. I think that was 4 billion years ago, which makes this look puny. Here's showing more of the compressed nature of all the different major events in history. This is where we are right now. Anyone who's saying this will definitely go well, I think that's overconfident. Sometimes unexpected things happen, but maybe a counterargument is also some of these predictions don't pan out. Overall, things are hard to predict. You can look at how well sci-fi writers actually did at predicting the future. This is Isaac Asimov. Some researchers looked through some different predictions Asimov made, as well as 2 other famous sci-fi writers. Asimov did the best of them at predicting the future. And yeah, you can see this is like reasonable. And I would argue that Asimov wasn't even trying that hard to predict the future, like doing heavy, big, effective altruism reports on what the future might look like. So maybe we can do even better at predicting the future than the sci-fi writers. Overall, it seems like sci-fi predictions can come true, and our world is increasingly becoming quite sci-fi. Things advancing really quickly. We won't have much time to work on relevant safety progress we need and a bunch of other stuff that we might need. Worlds might have trouble coping with all the different things that change really rapidly, and maybe we're going to rush and make some bad decisions that then last for a long time. 2 things. So one, this is the AI incident database. If you want to just look through different incidents that are happening with AI, I think it's supposed to highlight bad things AI is doing today. But the second thing was, it's getting close to just a Black Mirror episode. Things are changing really quickly and rapidly, and maybe we shouldn't be going so quickly. Another thing is, a lot of our life is already controlled by AI. If you spend any time on social media, that timeline is going to be heavily picked by artificial systems. The music you listen to, the apartments you buy, even the people you date point to maybe the world just becoming increasingly complex. So many different tasks are automated that it slips out of control, not just for any individual human, but overall, even for large groups of humans trying to change things. There won't be much we can do. It'll be mostly in the hands of automated systems. It could be pretty easy for that to go wrong. Those systems are measuring something easy to measure, like user engagement. So Facebook was maybe a case in point of this, where they tried to get people to spend like a long time on Facebook, and then maybe this had deleterious mental health consequences. Putin said, whoever leads an AI will rule the world. He also said he doesn't like monopolies of AI technology. This is a bit taken out of context. And he also didn't stare evilly into the camera while he said this. He was addressing school children about the virtues of technology. Maybe if you don't think Putin is going to be a very good governor of whatever regime he's operating, then you wouldn't want him to have access to really powerful technology that could potentially reinforce the strength of an oppressive regime. People might react too strongly to this and say, oh, we need to rush ahead and get to AI before Russia and maybe more commonly before China. This seems like it's ignoring that potentially getting to really advanced AI is on its own going to be catastrophic to everyone. It's maybe a misidentification of where the bulk of the risk lies, and saying, I want to be the first monkey to get the poisoned banana. But oppressive regimes can definitely be fueled by AI. This was about a year ago. You had to look hard to find deepfakes. These days, you can just Google deepfake and find lots of examples. This one is a fake video where Putin declared that the Russians were surrendering in the war. But you could imagine a more pernicious video, like Putin declaring a nuclear strike on the United States and some of the havoc and mayhem that might cause. It's importantly not the case that if we identify the video as fake, if Twitter says stay informed 3 hours after its release, that this doesn't undo all the damage of the video. It's also important to note not to think from our own individual perspectives about the risks of misinformation. Like, we deal with a lot of misinformation today, but I'd argue that some segments of society don't deal with it very well today, or don't even care about being misinformed that much. And maybe QAnon conspiracy theorists would really go in a negative direction with a bunch of AI-powered videos. Another risk is building weapons of mass destruction. Now, this is at the same time misuse risk of humans misusing it, and also just a nice attack vector for harming a lot of humans at scale. Symbols here: nuclear weapons, which we have thankfully avoided an all-out nuclear war, but you might know that we've come pretty close to an all-out nuclear war. Biological weapons, also familiar to a lot of effective altruists. There could be things much worse than COVID. And chemical weapons. There's famously in the news one AI system that designed chemical weapons far deadlier than the deadliest ones we have today.
It takes like a grain of salt to kill someone with VX, this nerve agent. And this AI on its own, they ran it overnight. I forget if it was just for fun or a mistake or something. And it found plans to make things that could kill a human with 1/10 of a grain of salt. And it also found VX itself and other different compounds that were already known to be really dangerous. AI can definitely be good for finding weapons of mass destruction, making plans to build weapons of mass destruction.
Stuart Russell, famous AI researcher, says the Russian ambassador said these lethal autonomous weapons are 20 or 30 years off in the future, while actually with 3 good grad students and maybe a few robotics runs, you could do this in 1 term. Maybe that's 8 weeks or 12 weeks or something at Berkeley. There's a common phrase of racing to the bottom. If you're trying to move fast, maybe you'll be less cautious. So let's flesh this out with first one example. Micah, who runs the alignment team at OpenAI, said maybe we should think before we just integrate the biggest language models into the economy everywhere. And then I think March 17th, maybe this was a week later, it just said, let's integrate them into the economy everywhere. So the plugins let you access Zapier and other different applications. So you can connect GPT-4, I believe, or at least ChatGPT, to an application programming interface and have it do a bunch of tasks on its own. Some theory here. Why are bad things going to happen? There's probably a difference between a system that's safe enough to deploy to make money and a system that you should actually be deploying that's actually good for the world. In the process of
going from the less safe to the actually safe system, you might have to pay a bunch of costs. One might be the actually safe system is just worse at the task overall. Maybe it has to scan
the outputs it's about to do to see if they're dangerous, and it's just slower to users. Maybe the researchers have to work on it for 6 months, like in the case of GPT-4. They had it finished in August and they didn't release it until March. That was because they did a bunch of testing and alignment related research. So 2 things on that. One, that slows you down by 6 months. If you're trying to beat someone else to the punch, you might not be willing to spend that time. And also you just have to pay the researchers to do that research rather than other research they could be doing. So alignment taxes seem to be a dynamic that could make people less cautious.
Wanted to give the audience a chance to ask questions.
You were mentioning 20 watts for human brains at some point. Yeah, 10 watts, I think is what it is. I was reading that recently. And then I was thinking about a lot of the timelines you were citing seemed a bit slower than more recent timelines I've seen. Most notably, Metaculus over the past year has brought up their median prediction 20 years or so. I'm wondering, what do you think about these accelerating timelines? And then I propose that MEMS outperforming expectations in the AI safety and capabilities research sector might be one reason why people are now going a little bit more forward with their timelines.
This report, which is from Epic, took into account pretty recent Metaculus timelines. I do know there are 2 popular Metaculus AGI forecasts, and one of them is much less high of a bar than the other. I think people feel more strongly that timelines are short now because I think we heavily anchor where we think things are going based on what's our current experiences. Things right now seem really impressive. They come out at a really fast rate. I do think there's some expectation that it will be getting harder to harness large amounts of compute. There might be some bottlenecks we're hitting somewhat soon that don't stop progress, but make it harder to continue at the rate it's going.
Thank you.
Was the question something like, why are LLMs performing so much better than people expected?
I've got my own kind of thoughts on that. No, it was mostly just this impression that a lot of AI safety timelines that people were proposing a year or 2 ago have kind of been too slow or been since updated to be much faster.
We might look at the Metaculus forecast and say, oh, what's the year? What's the year? But if you think of it as a probability distribution, even here, it's like, 30% by 2030. That is very high, but so is 12%. Timeline shifting matters. Some of these lower numbers were 8% if we look at all the model-based predictions. That's very high as well. So from a perspective of should we take the risks seriously, Metaculus just adds to that claim.
Yep. Thank you.
I enjoyed the presentation. I was curious of your thoughts on whether you think there's value in learning empathetic talking or deep canvassing to try to influence other people more involved in AI capabilities research and even some of the higher ups in those firms. And also whether if you're not getting through to them to potentially slow down or take whatever precautions we think valuable, and whether it's worthwhile to try to influence, I don't know, some of their friends, some of their neighbors, some of their family members, especially if we think we are on a shorter timeline than we used to think.
So basically your idea is maybe we can talk to the people in power and try to get them to slow down. Is that right?
Yeah. So deep canvassing is a method used in certain campaigns for swing voters. It's a longer conversation. You really listen to them. You talk more on the basis of principles. And you're not particularly aggressive. There could be potential in direct conversations with the people in power. And again, if that's not working, then trying to sway some of the people in their lives to have those conversations with them. It's one potential method, even though there could be some risks to it as well. I don't know if they get pissed that we reach out to their spouse or something.
Yes. Okay. The good news and bad news. Good news is someone was already working on this. So if you look up Vale Gates on the EA forum, there are some posts about doing outreach to ML researchers. The bad news is it didn't really work that well. A lot of researchers didn't change their mind that much. I do think this is important to consider. I think it's a really promising thing to do. So that's the short answer. The longer thing is, yeah, there are big risks. For one thing, I think I heard someone from DeepMind's alignment team saying, it looks like
A lot of AI researchers could probably 10x or more their contributions to AGI.
if they switch career paths a little bit. A big risk is you just tell them about this and they say, well, it seems really cool to build these powerful systems. I don't buy the risks part and I'll just build them. And then you just end up making things go even faster. And there are quite a lot of others, although it's important to think about the downsides carefully because a lot of seemingly good actions actually have big downsides. The road to hell is paved with good intentions in some cases. This gets brought up a lot as a strikingly crazy finding. A quarter of respondents in a survey answer it's impossible that we'll have AI causing anything as bad as human extinction. A lot of polarization. So almost half of them say, no, 10% or more. Whoa, the community is divided. What industry do you have where people work on their thing despite thinking it's 1 in 10 chance of causing a huge catastrophe? 10% is pretty big. Imagine you have 100 pills and you randomly choose one and 10 of them are poison. How willing would you be to do that when instead of you dying, it's everyone on Earth dying in the case of maybe an existential risk? Startling that this many researchers reacted this way and still work ahead. Something to keep in mind is people are aware of the risks. There's Jeff Hinton, central figure in deep learning. He said he didn't expect AI to be achieved for decades. So maybe that's why he's not as worried or he's fine with working on it. But he says, I think things are hopeless. And Nick Bostrom says, you think AI will not be a cause for good? He says, yeah, I think political systems will use it to terrorize people. So that's maybe his threat model. And Bostrom says, then why are you doing the research? Hinton says, I could give you the usual arguments, but the truth is that the prospect of discovery is too sweet. It's a nice New Yorker article, parallels it to Oppenheimer, who talked about the nuclear bombs, saying, when you see something that is technically sweet, you go ahead and do it, and you argue about what to do about it only after you've had your technical success. They asked him, can AI be controlled? He says, that is like asking if a child can control his parents. It can happen with a baby and mother. There is biological hardwiring, but there is not a good track record of less intelligent things controlling things of greater intelligence. He looked as if he might elaborate, and then a scientist called out, let's all get drinks. Maybe part of the problem here is overall, the world doesn't think that much about the risks of things we do. Like a lot of people are motivated by individual incentives. I want to have a good life. I want to make money and have a nice career. And I'll do the things that are cool and interesting and intellectually stimulating. Or maybe Hinton will change his mind if he thinks AI is closer and nearer. But yeah, this is one of the top AI researchers. He won a Turing Award, which is one of the most prestigious awards you can win in 2018, along with, I think, like Yoshua Bengio and Jan LeCun, some of the fathers of deep learning. Maybe you can just think of it as people don't think that hard about the risks of the research, or they just maybe intellectually agree, but emotionally don't feel any harm there. There's also this Sam Altman interview you can check out. He said, I think people are thinking we're doing the wrong things, but I truly believe that this incremental progress where we build better systems and test them and align them and then go forward is the best way. And Lexus. But it does feel deeply non-consensual in that maybe you think this is the best thing to do, but you're very much just dragging everyone along with you for the ride. Another top AI researcher, Andrew Ng, used to say, I don't work on preventing AI from turning evil for the same reason I don't work on the problem of overpopulation on Mars. Since then, the YouTube video that was originally from was taken down. So I don't know if he changed his mind or something. Rob Miles made a little illustration of why this might be a flawed way of thinking, where a bunch of humans say, we're going to go to Mars. And people say, what are we going to do when we get there? And they said, we'll figure it out when we get there. And then people say, do I have to come to Mars? I don't really want to go to Mars with you. And they say, no, everyone's coming and it's going to be great. I hope this was taken out of context, but Sam Altman, who's maybe the most powerful person in AI, leader of OpenAI, says AI will probably most likely lead to the end of the world. But in the meantime, there will be great companies. Maybe this was taken out of context. I hope. You can't access the original Business Insider article that it's from. There is some maybe call for saying, whoa, this is not okay behavior. But yeah, I do think we should try to talk to people and we should be very respectful. I don't think it's good to say you're an evil person at all.
Thank you. Yeah, I appreciate your response.
Harrison is next.
Thanks so much for doing this. My question is basically, seems like one of the major problems with trying to persuade other people of risks here is just that it's like kind of illegible. It's hard to point to rigorous methods or other things that someone would look at and say, yeah, I agree with that, or I trust these methods, and then you show them the results of those methods. One good thing here is pointing to experts, even if it may not be the best thing, it seems like it's helpful. But aside from that, what would you recommend if someone were hypothetically trying to explain to the director of science and technology policy why they should care a lot more about AI safety? Would you perhaps bring up the scaling hypothesis, or do you think that maybe too like sci-fi and not well established yet, or what would you recommend?
Yeah, communicating about things is tricky. There's definitely a risk where you just convince someone the technology is powerful and they aren't convinced of the risks part, and then they just become interested. We've got to beat China to this, because the solution is to have everyone with their own really powerful AI and the fires will burn each other down or something. That's a caricature of the view, but it's common for maybe a policy type thinking. We need to be the first to get this technology before our rivals and adversaries. The things that would bring up, one, difficulty of getting people to make a decision. So I think the alignment text is a really important concept, why people might be less cautious. Two would be some of the existing research on AI alignment. Some of that can help with capabilities as well. Depending on who they are, you can try to walk through why you think things are actually going to be a risk. People tend to resonate pretty well with the interpretability thing. It's a black box. That's dangerous. That works. Although it doesn't feel intellectually totally honest, because that's not on its own a reason to be scared. There's more nuance to be added there. Maybe the conclusion of saying it's a black box is that we're not going to be certain about how it's going to act. And also we might have trouble dealing with some of the control problems we could face in the future. I'm going to wrap up my answer. I would think through the risks really carefully, and I would look at the messages to spread for AI safety. That's some of the motivation for this talk, with some different messages that seem robustly good to spread. And there are probably others. As far as I know, this is the only in-depth look at this question that you're asking right now.
Okay, so David asked, what about the S-curve, essentially? Why are AI capability graphs only assuming exponential growth rather than an S-curve? Are there people considering that there will be a ceiling to AI growth/capabilities, similar to how Moore's law is slowing down or how self-driving cars are less bullish?
It's definitely a possibility. You can't just continue a trend on a graph in a straight line, or even, oh, it looks exponential, so it's going to be exponential. Maybe there will be some limitations. I think you do have to look specifically, what are those limitations going to be concretely? Some people have looked a little at this question. There was a report from Center for Security and Emerging Technology, CSET. It's called AI and Compute. So maybe looking a little bit there to see what some of the forecasts are. Main drivers of AI progress tend to be computational resources, data, and algorithmic improvements, like software, hardware, and data. You can try to think if you think there's going to be some slowing down there. As for more of, is there going to be a fundamental limitation to intelligence? I'm a bit skeptical. One, it seems evolution/natural selection was the algorithm that led to human intelligence, and it could have easily been run for longer, maybe, and come up with something more intelligent. It also seems like humans have a bunch of biological limitations. So simplest one is our brain has to be a certain size. It can't be infinitely large. It can't be 10x larger, because we would fall over. So with AI, it's much easier to just take whatever is currently working, whatever recipe is giving you your intelligence, and scale it up further. There's also stuff like the nerve conduction velocity in our nervous system, neurons, and the rate at which a computing device fires. A100 GPU fires, I think, 1,000,000 times faster than the estimated firing rate of a human neuron. So you can do these sort of biological hardware comparisons. And it seems like maybe there's going to be a lot of advantages to getting intelligence out of computational resources.
Okay, thank you so much, everybody, for coming. That was really wonderful.
Thank you, everyone, for coming.